These specialized cleaning compounds keep America's $400 billion plastic manufacturing industry running smoothly, yet most people have never heard of them. Purging compounds are the hidden heroes of plastic production, quietly saving factories millions of dollars while ensuring the quality of everything from your car's dashboard to your kitchen containers. Walk into any plastic manufacturing facility today, and you'll witness an intricate dance of heated barrels, spinning screws, and molten plastic flowing through complex machinery at temperatures exceeding 500 degrees Fahrenheit. But what happens when that black automotive part finishes its production run and the next order calls for pristine white medical components? That's where the magic of purging compounds comes into play. The problem facing plastic manufacturers seems simple, yet becomes catastrophically expensive if ignored. Every time a machine switches from one color to another, or from one type of plastic to a different material, residual polymer clings stubbornly to the internal surfaces. These remnants create what the industry calls contamination events, black specks appearing in white parts, color streaking that ruins entire production runs, or material incompatibilities that can damage both the product and the machinery itself. For decades, manufacturers tried solving this problem the hard way. They'd run virgin plastic resin through their machines, hoping the new material would push out the old. Some facilities even resorted to homemade solutions. Baking soda and laundry detergent were actually used by desperate plant managers trying to clean million-dollar injection and molding machines. As one industry expert puts it, using regular resin to clean these machines is like washing clothes with only water, instead of using laundry detergent to remove non-water soluble stains. The breakthrough came in the 1980s when the first commercial purging compounds hit the market. These weren't just random plastic pellets, they were engineered cleaning solutions designed specifically to tackle the unique challenges of thermoplastic processing equipment. Companies like Dynapurge and Asahi Kasei pioneered formulations that could chemically break down stubborn residues while mechanically scrubbing away deposits that had been building up for months. Today's purging compound market tells a remarkable story of industrial innovation. The global market reached nearly $800 million in 2024 and is projected to exceed $1.3 billion by 2034. That's not just growth, that's validation of a technology that's become absolutely essential to modern manufacturing. Asia Pacific dominates this market with 37% of global share, with China alone accounting for nearly 20% of worldwide consumption. What exactly are these miracle compounds? Think of them as specialized detergents designed for extreme conditions. There are three main categories, each engineered for specific cleaning challenges. Mechanical purging compounds use physical abrasives, tiny glass fibers, calcium particles, or talc that literally scrub the inside surfaces of barrels and screws as the machine operates. These compounds are heavier and thicker than regular plastic, creating the force needed to dislodge stubborn buildup. Chemical purging compounds take a completely different approach. Instead of scrubbing, they attack residues at the molecular level. When heated, these compounds release active chemicals that break down the bonds holding contaminants to metal surfaces. The residue essentially dissolves and can be flushed away with the purging material. This process often requires what's called soak time, anywhere from 5 to 30 minutes, where the heated compound sits in the machine, chemically eating away at years of accumulated deposits. The newest innovation combines both approaches. Hybrid purging compounds offer the immediate mechanical cleaning action with the deep chemical penetration for the most stubborn contamination. These represent the cutting edge of purging technology, though they typically cost more per pound than single-action compounds. The economics of purging compounds reveal why smart manufacturers have embraced this technology. Using virgin resin for cleaning might require 10 times more material than a commercial purging compound to achieve the same results. More importantly, virgin resin takes 3 times longer to work, translating to costly machine downtime. John Pizzo, a technical expert at Aceclean, puts it bluntly, frankly, using in-house material is the best way for a company to lose money. Consider a typical color change from black to white in an injection molding operation. Without proper purging, black specks will contaminate the first several hundred white parts, creating immediate scrap. The cost cascade is brutal: rejected parts, wasted material, machine downtime for cleaning, delayed delivery schedules, and potentially damaged customer relationships. Industry data shows that purging compounds help facilities reduce scrap production by 40 to 50%, while saving over 30 minutes of machine downtime per shift. The mathematical reality is striking. A single facility can save more than $50,000 annually just from reduced downtime. When you factor in decreased scrap rates, improved product quality, and extended equipment life, the return on investment becomes compelling. Michael Muth from Slide Products explains that a processor can conceivably cut the purge time on a machine from 2 hours with an in-house material to 45 minutes with a commercial grade. Purging compounds do more than just clean. They protect expensive equipment from premature wear. Thermoplastic processing machinery represents enormous capital investments. A single injection molding machine can cost hundreds of thousands of dollars, with the barrel and screw components being particularly expensive to replace. Regular use of purging compounds can eliminate the need to physically remove screws for manual cleaning, a labor-intensive process that requires shutting down production for hours or even days. The technology has evolved dramatically since those early 1980s formulations. Modern purging compounds are engineered for specific applications and materials. Some are designed exclusively for polycarbonate, a notoriously difficult material that leaves behind black specks. Others target the unique challenges of medical device manufacturing, where even microscopic contamination can render products unusable. Food safety has driven another wave of innovation. Ultraplast purging compounds, for example, use only FDA-approved ingredients that are generally recognized as safe for food contact applications. This allows food packaging manufacturers to clean their equipment without worrying about introducing harmful chemicals into the food supply chain. Environmental concerns are reshaping the industry as well. Over 70% of newly introduced purging compounds in 2023 were halogen-free and compliant with European Union environmental regulations. Companies like Clariant have developed biodegradable formulations specifically for packaging applications, addressing the growing demand for sustainable manufacturing practices. The latest frontier involves artificial intelligence and predictive maintenance. Advanced sensors now monitor polymer degradation in real time, automatically triggering purging cycles before contamination affects product quality. This AI-driven approach minimizes human intervention while optimizing material usage. Some systems can even predict the optimal purging schedule based on production patterns and material characteristics. Liquid purging compounds represent another significant advancement. Unlike traditional pellet forms, these liquids can clean equipment without requiring disassembly. They've seen a 15% increase in demand over the past 2 years, particularly for equipment with intricate geometries like hot runner systems, where traditional mechanical compounds might cause damage. The global reach of this technology is impressive. Aziclean, one of the market leaders, reports customers in over 77 countries with more than 2,000 active users worldwide. This international adoption reflects the universal nature of plastic manufacturing challenges, whether you're producing automotive parts in Detroit, medical devices in Germany, or consumer electronics in South Korea. Contamination control remains critical. Yet despite proven benefits, adoption hasn't been universal. Industry surveys reveal that many manufacturers still resist commercial purging compounds, clinging to old habits and in-house solutions. This resistance often stems from the upfront cost. Purging compounds can cost significantly more per pound than the production resin. However, this perspective misses the crucial distinction between cost per pound and cost per purge. The total cost of cleaning, including material, labor, and downtime, almost always favors commercial compounds. The challenge is compounded by the lack of industry-wide performance standards. With over 150 different formulations available globally, comparing effectiveness across products remains difficult. A 2024 industry study found that 45% of users reported inconsistent results even from the same manufacturer, highlighting the need for better quality control and standardization. Looking ahead, several trends are shaping the future of purging compounds. Sustainability will continue driving innovation toward bio-based and recyclable formulations. Smart manufacturing integration will make automated purging cycles standard practice. And as plastic recycling becomes more sophisticated, specialized compounds for processing recycled materials will likely emerge. The technology that started as a simple solution to color contamination has evolved into a sophisticated system that touches every aspect of plastic manufacturing. From the medical syringe in your doctor's office to the automotive components in your car, purging compounds have quietly ensured the quality and safety of countless products. This hidden world of industrial cleaning represents more than just operational efficiency. It embodies the continuous innovation that keeps American manufacturing competitive. While consumers may never see purging compounds in action, their impact resonates through every plastic product we encounter daily. In an industry where contamination can mean the difference between profit and loss, these specialized cleaning compounds have become the unsung heroes of modern manufacturing, proving that sometimes the most important innovations are the ones working behind the scenes. Make sure you subscribe.